Testing your broadcast. That's a nice way of putting it, YouTube. Are you testing me? I find you very testing. Oh, I'm live. I am live according to the broadcast simulation that I've got in front of me, and I am live, so that's good news. Let's pop it up. Yeah, there we go. That's working. Welcome to Amberskies. My name's Fraser Sharp. Just call me Blades. Call me anything you want, really. It doesn't matter to me. Right, where are we up to? That's right, camera 3D. Okay. We left yesterday with a transform class, which didn't seem to do much. Well, it doesn't do anything at all by itself. What it does is it enables us to transform properly in any way that we see fit, and that will probably be used here with the camera 3D. Let's make a class, and we're going to call it Camera 3D. Why not? Camera 3D. Yes, we are cooking on gas. No messing around here, you know. I'm just going to put public here, I think, because I want to do something stupid. I want to make some variables. Let's do the normal ones first. So we're going to have our bool. Again, has changed. Okay, we know what that's all about now, I hope, after yesterday. If you haven't seen yesterday's video, watch it. I'd advise you to. We're going to have our Q vector 3D. And this is going to be our translation. Now, I also was a bit hesitant in, are we going to use this class? I thought about it now. I think we possibly are. Let's have our quaternion. There we go, we can have one of those now. Remember, all of these headers are included in... I'm in the wrong place. I'm not even in the header file. Hello, are you awake today, Blades? No. Right, let's be in the header file, shall we? That might help. In the transform class, we have all of these includes, so they are included from transform.h. So all we're doing is we are repeating what we have in there. Yes, this is rotation, of course. We know why that's now 4-dimensional and not 3-dimensional. I think we've been through everything on that. And we better hold a Q matrix as well, just in case we need it, for x4. Yeah, for the world. Our world matrix for the camera. We don't hold the view matrix for the camera. That's done in window, in the window 3D. The window is responsible for doing the perspective and things like that. So we don't hold it here with the camera, we hold it there. So as long as you know now that we've got the world and we've got the view, there's only the model matrix to go, and the camera doesn't have one of those. We don't have a model for the camera, which is why I'm thinking we're going to use this. Now I'm going to do something strange here. I'm going to do something that I don't normally do. I'm putting variables in. And it's because I want some static consts. Or constant expressions, or whatever you want to call it. No, they're not constant expressions. It's a static const. It's a Q vector. 3D. And I want 3 of these. The first one we're going to call local forward. I'm going to explain this in a second, don't worry. The next one we're going to call local up. And the last one we'll call local right. Alrighty. Why have I done that? Then we'll put in camera 3D. And that'll do. Alright, let's pop you in. Got our definition now, that's good. Save. Again, I'm not putting empty in this one because I don't know yet. Save that out, all done. And this gets a bit interesting because I'm not going to start there, I'm going to start here. Before our class. So let me just look at my notes. Yeah, I remember this. Oh my god. Oh, this has been years. This is years and years old. That's a nice drink. Local forward, local up and local right, Blaze. If you're going off your rocker, no. Because that's what we're going to be using for our rotation. Instead of using the X, Y and Z axis of the world, we are going to be using local forward, up and right to do our rotation. And that is going to be the what is directly up from the camera. So if you roll the camera, which way is up? And this is the whole problem that we haven't solved yet. And this is the first time we're going to solve it by using this. So this is how we're going to do it. We're going to have a const Q vector 3D, and then it's going to be camera 3D colon. Here it is. Here they are, local forward. And we'll put this as forward will be 0.0f. It'll be at the center of the universe to start off with until we change it. And it will be facing forwards is minus 1.0f, or into the screen, which is north. I'm going to call that north. Alright, just as a reference point in my own mind. That's only for programming, really, so I can relate to it as a world thingy. May as well, no, it doesn't matter. Yeah, I should really do this, because we're going to be using this multiple times now, aren't we? So what we're going to do is we're going to set up, or how can you put it? Define these variables and set them up to what we want. So this one's going to be a local up, and that's the Y direction, and that's going to be 1.0f. Okay, does this make sense? From what you've seen so far in all of the programming that I've done on YouTube, I'm hoping that this makes a little bit of sense, even if it's not clear. If you do need clarification on this, please say so in the comments below. I'm more than happy to do a full video on world and local, the difference between world and local coordinates, and how many coordinate systems there are in 3D. And there's an awful lot. There's an awful lot of coordinate systems that happen. So it's very confusing, I think, for beginners. And I've just done it, haven't I? I'm going to just Control V. And it's local right. We only need one X direction, so we're using right. We could have used left, but right is positive, so we'll use that one. Why not? Because we can. There we go. So yeah, You've never seen me do that before. It's an interesting idea because those are public, which means that they can be accessed from outside of the class. So we can access, what we need to be able to do is to be able to access where the camera is, but we also really should be able to access which way up it is. And that is pretty important at times to know, especially if you're flying a plane or something like that and you want to control, put in like plane type controls or spaceship controls or something like that in a game. Having access to that is good, but remember, if you access them, they're all const, so you can't change them. Only this, only camera 3D can change them. If you access them from outside, ain't gonna work. Right, do I need anything in camera 3D? Probably not. Right, I can't think of anything straight up. There will be something. What we just put in here? Oh, God. So, has changed, we'll have. Oh, God, I wish you would do that. Thank you. Let's do that then. What can we do? We can do has changed. And it should be M has changed. Really, it's a member. So M has changed is false to start off with. I'm just thinking, yeah, we can do that. Yeah, M underscore translation. That's just going to be a Q vector 3D. And open brackets, and we'll just put the zeros in. F. I sometimes like to put an offset in, but I'm not going to. I want this to be clean for once. Okay. Next one is rotation. I've learned how to do this now, so after doing the last part, so it's Q quaternion, colon, quaternion, open close, sets it to identity. I've read the instructions and that's what it tells me to do, so that's what I'm going to do. mworld. Oh, right, this is the one we can't do. Right, yeah, this is the one that has to drop down. Okay. So, yeah, I knew there was something I couldn't do. mworld. Dot set to identity. Okay. There we go. And that is our constructor. That's our proper constructor, right. Lovely. What's wrong with camera 3D? Why is it still underlined? Thank you. Right, we're finished with the header for now, because I don't know what to put in it. I know what to put in it, but I just want to make sure I'm thinking correctly here. So, what we got? Camera 3D. There's no destructor. because it's not going to have anything with, there's going to be no pointers in here. Alright, what shall we have? We shall have a void. Let's start with a void. And let's start with translation and rotation. There's no scaling involved. So let's do translation and rotation first. So we'll do translate. We will need a const q vector 3D address of delta translation. I'm trying to keep this the same as I did with the transform, so it goes together with it, and it means we can reference back to these two and build the code for the next bit. I think that's only fair. Okay. There we go, that creates its declaration. Thank you. I'll have a space though. Alrighty. So m underscore has changed equals true if this is called. Know how this works now, don't you? You can start to see a pattern. And m translation equals well, plus equals, and that's just going to be delta translation. Okay, it's looking good so far. No, I don't want anything else in here. That'll do. So we've got to translate. Void camera 3D rotate, and we're going to take in a const I don't like yeah, const q quaternion and delta rotation. If you're wondering why I use delta, it means change in, or change of, a change, a value change. Latin, I think it's from Latin or Greek, or Latinized Greek, possibly. Rotation. God knows. Wouldn't believe I did Latin, would you? I still don't know. There we go. There is our lovely thingy there. Didn't really want that spacing, did I, after all? Never mind. So how are we going to do the rotation? Well, has changed. Just do it as we've always done it, true. And then we're going to work out the rotation. And we need to do the rotation in exactly the same way as we did it in the transform. And if I can remember rightly, all we did was multiply. But we have to multiply in the correct order. So it's not star equals, because it's delta rotation goes first. And that's important. It's a bit like matrices. The order of matrices matters. So we'll times that by m rotation. Yep. Okay. That's you done. Setters. So we can do a set translation and a set rotation. Okay. I'll pop that in there. Yeah, I'm actually going to write setters out. Setters are always void. And that will be a set translation. And we are going to take in, what have we took in up here? I want that. No. No. Const. Q vector 3D. Let's do it properly. And it's just translation. That's a better way of putting it. That makes more sense to me. Got to get the wording right or it doesn't make sense, unfortunately. And of course it's put it there. It's just being awkward. As is the want with Microsoft. We'll just crowd it up and we'll sort it out after. Stuff it. I don't have much patience for Microsoft anymore. Equals true, as always, because we're changing it. And all it is m_translation equals translation. That's that one done. Void. Set a rotation. This is interesting. I'm going to do that one. We'll have a const. Quaternion. We'll take the address. And we'll just take a rotation. Any rotation will do. Alright, that's been listed in there for a sec. M_ has changed. You've already guessed now, you could have written this yourself after yesterday. Equals true. I showed you how to write this yesterday. So nothing that I'm doing today has changed. It's exactly the same. M_ rotation equals rotation. There we go. Right. Let's get complicated now. Let's write the getters. That's your setters done. So now we can put in here getters. Yeah, that'll do. And for getters, we are going to do const Q matrix, because that's what we're after. We don't really care about much else. What we are after as the end result really is the matrix of the camera, so we can use it in our shaders. So we want a Q matrix 4x4 address and it's going to be camera 3D. I'm going to call it how did we word it last time? Get matrix. Okay. And yeah, this is exactly the same as it was before. So really, we're writing the same class twice. And I'm doing it on purpose because I want those transforms to match everything and everything everywhere. Create declaration, ding, and it puts in the wrong place. Should have known it was going to do that. Okay. Now, how do we do this one? We say if. I mean, you already know that you've already got the answer. Has changed. So if it's changed, we'll calculate it. If it's not changed, we're just going to return the matrix. Whatever it is. M-world. I remember now. So let's calculate M-world. So M underscore has changed. We have to reset equals false. Reset to its initial condition. And then all we need to do now is M underscore world dot set translation. No, set to identity. Do the right one. Always set it to identity before doing the calculation. So it's just we just want to do a rotation and translate, don't we? Yeah. Underscore world. And it's dot rotate. And it's the reverse because it's a camera. This is the only bit that changes. So it's M rotation. And now how do you get the reverse of a rotation? Put a minus in front of it? Nope. You can't do that in this kind of maths. We have something called a conjugate. Okay. And this is coming off a matrix 4x4. Alright, let's take a look at that. I mean, I've typed the line and it's perfectly correct, but I just wanted to show you that that I did read the manual. I'll show you. Where am I getting this information from, basically? How do you research this kind of information and where do you get it from? I think that's more important than the code, to be quite honest with you. Okay, let's have a look. Q matrix. So if you look at Q matrix 4x4, it doesn't come up. Great. Oh, it does come up. Q mat torex 4x4, that one. So this is included GUI and GUI. And if you look down, we've got all of these lovely things we can do with it, like scale it, translate it, which I've already used. And where's the conjugate gone? You just go straight past it. probably. Huh. Could be there. Why is it calling me a liar? Or have I just completely goofed again? My eyes aren't too good again today, so... Column const conjugate. Well, it doesn't even list it. 5.1. Ah, right. I see. That's why it doesn't list it. Why is it giving me Qt 5.14? Why is this giving me Qt 5.14? It's giving me the wrong Qt. My... Oh no, it isn't, it's 5.14. It should be in here. Construct, yeah, blah blah blah. Convert, create. Okay. I know it's there, because we've just done it. It's an obsolete member for Q quaternion. Ah. Obsolete. Why has it all become obsolete? Oh, it's because I was looking at the wrong thing, but... Hold on a minute. Why has it become obsolete? It's here. And it's ED. Right, got ya. It's been replaced by conjugate instead of conjugated. How goddamn weird. Returns the conjugate of this quaternion, which is minus x minus y minus z scalar, and that's why you can't just minus it. Why you can't minus the rotation, because it's only the vector part that gets minused. The scalar part doesn't. And it's marked as obsolete. And yeah, it's here. Conjugated. Yeah, okay, what did it give me here? Conjugate. Dot con. Oh right, it's got conjugate and conjugated. Right, conjugated is obsolete, we use conjugate. Right, okay, that's not very clear in the manual. So, that explains why I couldn't work it out, because my head was sideways again. Oh, head, don't go sideways. Now we have to just translate it, so... It shows that I can do this stuff in my sleep, doesn't it? Dot translate. And this time it is a minus sign, because we can, it's only a vector. M underscore trans. You're thinking, why have we got these minuses and conjugations? Simple. The camera faces backwards. Yeah. So the camera looks behind, it faces into the screen, not out of the screen. We see things coming out of the screen. We see our viewpoint is the stuff we look at as if out of the screen. Or we place models in there as out of the screen. but a camera has to look into the screen, so it's the wrong way round, in OpenGL terms anyway. It should make sense that the camera is the wrong way round. Maybe it does, maybe it doesn't. Interesting. Alright, let's have a look at what we have to do down here. Because now we've got to do all the weird bits. We've got to do a Q vector 3D. And this is where it all becomes very, very interesting. Because this is going to be forward. Okay. And we'll make it a const. So it can't be changed from outside. And what we're going to do, I could just write this in the... No, I won't. Because it's harder to look at and explain. Alright, because this will need a little bit of explanation. Forwards is literally... which way is forward to the camera? Not the world, the camera. So we'll pop it underneath get matrix because it is a getter, really. Or get forward direction, I could call it. No, I won't. So forwards. What we're going to return, we're just going to do it as one thing. So we're just going to do it as a ternary. Not a ternary, a return value. M rotation. Got to keep my language simple. We are going to a rotated vector, which is a function we can use, and we can use the local forward. Okay, that's the important part. So that's all we're going to do in there. But we're going to do that for forward, up and right, obviously. Forward, up, and right. And each time it's just going to be a local forward. I think you can guess if we change this one to up and this one to right. We'll pop you in. And we'll pop you in. And there we go. So rotated vector, local forward, local up, local right. So that's how we're going to be doing our rotations. What else do we need to do to make this work or workable? Nothing really. I think that'll do. Right. Let's have a look at our header file and see if we need to add anything here. I don't think we do now. I think that's our CPP done. That's you done. Here, I'll put space there. Public's done. Our locals are done. Local forward, local up and local right can be changed on the gets. Yeah, we've got them there. Okay. Yeah, I'm local accesses here. I'm not too bothered about. I mean, we could do get translation, get rotation, couldn't we? Or have I just done them? I have just done them, haven't I? We've done set translation, set rotation. We haven't done get translation and get rotation. So it's all going to be constant. Const Q vector 3D address get translation. In case somebody needs it, I suppose. And that's just going to be space const. Can't change it from that. Return. And that's just going to be M translation. Okay. And this is a Q quaternion. And it's get rotation const return m underscore rotation. That's that done. Am I happy with this bit yet? Not really. I think we've got enough there to do a camera. Okay. Yeah, we have. Okay. So, how shall we use this? That's a very good question. Alright, so I'm going to try using the camera in our window. Let's go to window 3D. Yeah, that's where I want our camera, so that we can access it. The only thing that we make when we enter Amber 3D SL is a window. So that's where we're going. We're going to actually, before I do, make sure I haven't forgotten anything. Alright, so it's building. That's good. It's building. So what we're going to do is here. We are going to do an Amber 3D. We're going to go down to our entities, and we're going to have a camera. I'm guessing we're going to have to make one, aren't we? Yeah. Might be a good idea. So, we'll pop it after Model Warehouse. Or no, we'll pop it before Model Warehouse. Why not? So what does it come under? Entities. We're in Amber 3D. So entities. Camera. 3D. Isn't there? Ooh. Oh. So where did it go? There. That's where it went. It's a storage class. It doesn't do much. Don't care. I'm going to use a pointer. To make my life easier. Now we've got a camera. A real camera this time. We can pop over into our window and we can control it. So in our window, and that's just going to be a new camera because it doesn't do anything. I can't even spell it today. Oh god. There we go. Model Warehouse second. Make sure I've got everything in the right order. You can go. Correct. That goes last. There we go. So we're just going to pop it in there very haphazardly and quietly. And yeah. Input update. If key pressed escape, this close. Update. Right. That's going to change. So let's do that next. This is the fun bit. Oh god. My notes are a mess here because I've got cubes everywhere. Yeah, we're okay so far. I'm just thinking that we could... No. We could... No. I'm arguing with myself. Help. Alright, let's do our camera. Okay. So, when we update our window 3D, we do the input update, we do the escape key, and then we update the window itself, which that just runs all the OpenGL stuff, which is somewhere around in the protected area. That just runs, not resize, that one. So it runs this. Realise we don't need that open. We don't need that open. We don't need that open. Right. We're not initialize. We might initialize it, but I'm just going to put a minus on there. Mouse events. Alright, yeah, well, it all depends on how I'm going to use it now, isn't it? Yeah, okay. Camera. How are we going to do it? Okay, if left or right mouse button. Right, the right mouse button. We'll do it in the standard RPG way, I think. Input. Do we have input? Did I put it in here? No, I didn't. That's clever of me. Yes, we have. We've got input.h. Class input, yeah. Which we can access because we're a friend. So input. Colon, button pressed, Qt, colon, alright. But, nearly got it. Just type it's easier. So if the right button is pressed, what shall we do? We shall handle rotations, I guess. So, yeah, okay, well, I'm going to do it all in here for now. Doesn't matter. Float. Trans. Speed. I wanted this at 3 meters per second, didn't I? We'll guess. How's about 1 point? Oh, that'll be way too high. 0.3. We'll try it with the 3s and see how close I get. We'll have another one as well. Static const. Float. We will have a rotation speed. That's better. We'll set that to the same. We're in degrees, aren't we? Yeah. Okay. How do you do the rotations? It's quite interesting. What you do is you take your camera, like that, and you rotate it. Like that. With minus rotation speed times the input colon, and we'll take the mouse delta. if I've got it. Yes, I have. Mouse delta. We've added that. That's good. Dot X. Comma. And this is where it becomes very, very important. It's local up. Alright, yeah, we can't do it that way, can we? Yes, we can. It's in entities. Yeah, that'll work. Local up. We should be able to access that direct. Looks as though we should be able to do that. I've just spelt it wrong. There you go. Minus rotation speed times the input of the mouse delta X. Yeah. Comma. Entities. What's wrong with this thing? Why are we not allowed to do this? Entities. Colon. Camera 3D. Colon. Local up. What's wrong with that? Too many arguments in function call. Which means I've done M camera rotate wrong. Right. Yeah, I've only got the quaternion. I'm going to need a different way of doing it. So X is a float and a vector. That's a quaternion. So I'm going to have to do a rotation for a float and axis. Or angle and axis. Alright, because this is very simplistic, isn't it? Right, so that'll be the first version of it. You see, and now I've got to alter this because I haven't done all the variations. So the other variation that we're going to need is a void. Rotate. I'm going to have to overload this. Float. Angle. This is an overloaded function now, don't worry about it. And a const q vector 3D and axis as an axis. Right, that's the overload. Problem is now we have to stop the window. See, it's now correct because we've got the overload in. Alright, it's done it. Alright, we'll just try a build, make sure I got that overload correct. Yes, C++, you can have one definition but multiple declarations. You can overload your functions. That's called function overloading, by the way. I've never shown you it, have I, really? What happens is, I've got the same thing with two functions. So those two functions will always go back to this rotate, which is a Q-quaternion. Now, a Q-quaternion, in turn, can take an overloaded function of that type because we have a float, well, we have a const Q vector 4D, we can have a float scalar Q vector 4D, and we can have a scalar X pos, Y pos, Z pos, so we can overload it with that one as well. That would be your third overload. So we may as well put them in. What the hell, let's put the overloads in. So the last one we would have would be void rotate. So you don't have to rewrite your function, you can just overload it. So it would be float angle float x well, it's not, is it? It's float angle x float angle y and float angle z. That's a quaternion. Right, no more writing to do there, that's all we needed. The same can be done for the translation. So we can have void translate void translate, and it'll take in exactly the same things. But it'd be distance, wouldn't it? No, it doesn't do it the same way. No, we can only do X, Y, Z. No, you can't do that one. It's not quaternion. Vector 3D. So that would be float delta X float delta Y. This is just overloading, giving you more different ways of accessing the same function. That's what overloading means. You can access these functions now in different ways. And it puts green squigglies under it because it doesn't understand what C++ can do. Thank you, Microsoft. You're stupid. We could do the same with the setters. Yeah, we can. So let's do that with the setters as well. Let's see if we can work it out from this one. So it'd be set. As long as it's the same name, same function name, you're fine. Because that there, QVector3D has a constructor for that. And on the rotations, yeah, we can just do these two, can't we? That would make it a lot easier. The same can be done in the transform as well. We could add all of those as well. So that's set. Actually, just do that, it's easier. Got to be the same. Have to be the same for this to work. That's correct, that's correct, that's correct. There we go. And they will convert to a quaternion and then be used in the function. So that's one of the handy things that C++ can do. This is how you can construct your own language and put variations in your language like you have in English, where you can express something differently and it will still mean the same thing. That's quite nice. Do we need to do getters? No. No. But what I will do is go back to our maths and make sure that our transform can do the same things as our camera. I want them to do the same things because we're trying to repeat things. So just in transform H. Thank you. Got it that time. So here we go. On the translation, we can have an extra translation. So it's that one there. (42) paste. And funnily enough, it's exactly the same thing. Isn't that nice? On the rotation, we can take those two across. May as well, now I've written them. So 44, B. We do have scale and grow. Scale and grow. Do I want to mess with scale and grow? We should do, really. I'm not really tempted to. I mean, what scale have we got? Well, that's the same as the translate, sorry. So yeah, we can add an extra scale. So it's the same as translate, it's the same as 42. Pop you in 48 there. And just call it scale. So once you've actually written it once, it's not too bad. The grow is the same. $50. Oh dear. We'll take that, yeah. Copy. Paste. That worked. And that should be correct. Yeah. They will convert to QVector3Ds. That's lovely. That's all I want to do there. Setters. We could do the same with the getters and the setters. I mean, the setters, yes. Getters, no. Okay. Copy. Paste. Why have I put all my setters with... Oh, God, I'm an idiot. I mean, how can you get something simple like this wrong? Oh, still got it wrong. That's right. So that's correct now. Rotation. Take you two. Copy. And paste. This is what I call basic calculation, mathematical. I don't even like these kinds of classes, but yeah, it's awkward for me because I just hate them. Oh, thank you. And we had an extra one on grow, didn't we? Copy. We didn't do a setter for grow. No, I didn't. Copy. And paste. There we go. And that's how to get, that's a very good example on function overloading and how it can all work. You can declare it in 3 different ways for one definition, as long as, and only as long as, everything else agrees. The Q vector, in this case, has to have a constructor for that. Otherwise it can't work, you can't overload it. So the overloading functions must have constructors that will work. Otherwise it just falls to pieces and becomes a very big mess and everybody's sad. Yeah. But that works now. So if we can do that for the x-axis, for rotation, maybe we can do this for the other axis. Yeah, I think we can. I think we can. Right, let's get back to this part now. God knows, what was I doing? I've forgotten now. Oh God. Brain's going out the window again. Here we go. Right. M camera, rotate. Lovely. That's as far as we got, right, okay. M underscore camera. And we are going to rotate again. Do it in the same way, I think. So it's going to be minus rotation speed. Minus rotation speed. Why can't it find anything? Because I'm spelling everything wrong. There we go. Input. Colon, and it's mouse delta. .y. So that's the X and the Y direction for the mouse on the screen. So there's only an X and a Y that you can do. And that will move our entities, or camera entities. Colon, camera 3D, colon, and that's wrong. Different. Don't like this. I don't like what I'm thinking. That's a Q vector 3D. Let's have a look at that. Where's it coming from? That's coming out of the Q vector 3D. No, it's not. It's here. Here we are. Rotate vector local right, yeah. Maybe we should use up. That one's correct. So if we go left and right, it'll go left and right. Up and down will go up and down. When we hit the top Y position, we'll gimbal lock. No, we won't. And this is a mistake I've found in flight simulators. Okay, stop and think time. Thinking 3D. Local up is straight up. Oh, well, actually, it won't be in the final game, but it will be a variable. Have to be set at certain points. Not everything's going to be local up in the Y direction. So if we set a well, we have set local up to straight up in the Y direction. If we leave it like that, then we will get a no, we won't. We'll get a 3-dimensional look around system for the mouse pointer in the first person shooter variation. If we use local up as the rotation vector, okay. If we change the up vector when we are looking up, it will work. You can still do movement either towards forward, local forward, or forward in the world. Ouch. Won't work. Okay, this is an FPS one then. It's not a vehicle one. Unless it's a ground vehicle or a ship. Interesting. It's how we are treating local up. What we're not doing is we're not changing it. Local right is being changed. So we know which way we're facing, which is always local forward. That will be 90 degrees to a local right. We don't change our forwards when we do that. Okay. Is it a quarterning? Yeah. That's fine, you don't need to. So the only local variable that we are changing with this camera is the right. Which way is left and right. We're not changing any of the others. We're not changing the forwards into the screen or the upwards direction, because neither of those need to be changed. For a 3-dimensional space vehicle, that would be completely different. We would have to handle rotations differently. Fine. That's fine. I don't mind. I really don't mind. Good. So that's it. That's if your right button is down, it will introduce these variables and the camera will rotate because it's going to affect the matrix that we take out of it at the end of the day. Lovely. Right. I was about to say we should. No, we could. do that. Hmm. Okay. Right, so what will we have? Let's have a Q vector 3D. Like that. And we'll just call it translation. The reason is I don't know which keys are being pressed down or how many keys are going to be pressed down at any one point in time. So you could have the W and the A key pressed down at the same time. So we need them all as separate if statements, not else's. No else's in there. What we need to do then is... Yeah. So if W is pressed, we will take our translation and we will add to it the camera forward. Yeah. Do it that way. That makes sense. Because that's got a 1 in a direction, or a -1 in this case. Okay. We will do... I'm just going to do this simplistically at the moment. The same here. Except we'll change that into a minus sign. This might work, it might not. The A key. Do the same kind of thing. That's going to be right. It's going to be minus right. The left. Okay. RIGHT. Minus. And the other one, obviously, is going to be positive. That's made that easy. We've got our rotation on the mouse. And we've got our forwards right being used for our direction. Okay. If you want to fly the camera up and down, you can. I'm not putting that in. I don't see the point. Which gives us a final calculation to do here. And that will be the changing for the M camera itself. So that will be translate, and that's going to be translation. Yeah. So that's our translation, and we will have these two have to move. Not going to work if I put them in there. They're scoped to that if statement. That's better. Now they're not scoped to that. Because now I want that translation speed, don't I? And I'll pop it in front of here. And we'll just do a multiply. There you go. There we go. So all we need to do now is pass that through. When we call upon our update. So we can pass it through in there, which is here. So we don't need the mouse position now. We might do actually. Okay, I'm going to put M camera here. That will alter the window H here. No, it doesn't. That will alter our model warehouse. Render all. We're getting close now. We are getting close. And that's in OpenGL. Change that to 3D. Change that to 3D. Okay. Change that to entities. Colon, camera 3D, comma. We can add that in now. That's all we have to do there. Make sure it's a null pointer for camera. It is. We don't own it. Don't delete it. Thank you. Initialize. Don't initialize a camera. Okay, render all takes in our camera. I'll just call it camera. I just want an address, thank you. Star camera. Got nothing to do with you anymore. So finally we've got rid of that stupid piece of code which should never have been there in the first place. Alright, I'm happy. Add texture, blah blah blah, check menus, not doing. M camera, now just becomes camera. Why is batch renderer? Oh, batch renderer is still using the wrong camera. Okay, so has a knock-on effect to our batch renderer. Okay. .3D. Now this becomes interesting. Because this does alter things. A little bit. One of these takes in the camera. I'm sure of it. Get texture, get color. Add texture, add color. No, it'll be in the next section then. Okay. Model, texture, color. Yeah, that's right. Okay, batch renderer. CPP. You've changed. That's fine now. That's fine. I'll always forget somewhere. So we are on the batch renderer. CPP. We're taking the camera here. The camera is not specified anywhere else. Okay, so draw color and draw texture ain't gonna work with that camera. Alright. Do draw color first. Do that. And do that. I think, no, there's an extra, there is another change somewhere. There it is. It's prepare instance we need to bother about. That's where the major change is. Yeah, okay. That's alright there. That's going to have red markers in here now. So you're the first. Prepare instance is where we need it. You're the second. Now, where's the camera bit? Create view matrix, there you go. Okay, how do we do it? The view matrix contains what? it contains set to identity, which we know about. Pitch, rotate, your roll, translate, get position. Right. Well, I've done all that. Yeah, done all that. Well, equals that. That should work. Yeah, that should work. I've forgotten something somewhere about. The camera is not used for anything else in here, is it? I have forgotten something. That was draw colour. Draw texture. Here we go. That changes that one. Changes that one. And draw texture. CPP. So we're not going to be needing this view matrix much longer, are we? If this works. That's everything okay there. That's that. And that's just... There we go. Now let's try. Oh, God, I missed something. In the mouse picker. Good God, I've forgotten all about this thing. Righty. Yeah. In model warehouse. Mousepicker.h. 3D. Three D. It may have to be used differently now. Can't see any more. Okay. Done the draws. Done the batch. Just finishing off model warehouse. The mouse picker. Again, create view matrices in. Three. 3D. M camera equals camera. Okay. that's easy then. Very easy. Alright, that's unfixed. Nearly right. Get translation. That gives back a QVector 3D. Yes, it does. That's handy. That's it. Well, considering the ease in which I've just done that, I'm saying that we might have coded it correctly. And we haven't broken anything. Right. Amber, 3D SL, rebuild, please. Now, the only thing we haven't done is set the initial camera position. So let's take a quick look at that before we try and use it. Right. Yeah. Translation. And we will take in for that float X float Y float Z. And void set camera rotation. Yeah, I can do it. Float angle X, comma, float angle Y, XY, bleh, angle Y, comma, and float angle X, Y, and Z. That'll do. That comes after set shader, doesn't it? Yeah. Yeah, it does. Good. Alright, so I've got those two now that we can use. This is our API that I'm starting to make now. Do we want to actually fill them in at this point? I'm not really sure. Construct constructs it, so yes we can, is the answer. So we can m_camera set translate and translation. What? Wrong camera. Alright, I'll be deleting that soon. That'll never work. That'll work. It should have given us an error. It never did. It didn't exist. I'm sure it doesn't exist. So how was it doing it? Yeah, set translation. Thank you. Get rid of you. Yeah. So I've got two variations. We can either use a Q vector 3D, or we can use delta x, delta y, delta z. Well, that's easy then, isn't it? X, comma, y, comma, z. There we go. Done. Set camera rotation. This is way too easy. Rotation. And that can take 3. We're going to need an angle. Oh no. I'll have to use that one. So we need an angle. Angle and a Q vector 3D. So yeah. Forget that. That's bad. Right. So we can't do it that way. And that's going to be a Q vector 3D. Axis. Angle axis. Yes, I understand what that means. That's good. So those are our two. Ah. Yeah. So it's float. Angle. Degrees. Make sure that you put that in properly, as it'll come up in the help hints for the user. And I'm setting it to degrees. Okay. Comma Q vector 3D axis. There we go. So we can now set the rotation to angle degrees, comma, axis. And that'll work. Lovely. So we can now set our camera at the beginning to wherever we want to. That's magic. Okay. And our camera will actually become, because of that, an ECS component. Interesting. Let's build that up to make sure I haven't missed anything. Crowds of time's ticking on. And I wanted to see if this worked today. I don't think I'm going to be able to get that far. You see, we have no reference in here to the camera at all. And at this point, I have no, we can't do it because we'd need an ECS to make it. We've got ECS, so we can make it. Alright, I think that's about as far as I can take the camera. What I can try and do is set it somewhere. Now, where did we have it set? I didn't look, did I? It might still be in there. No, I think I just deleted it, didn't I? Okay. Where did I set the camera? Oh, set it somewhere weird, that was it. I want to set it to the middle. Right, no, just doesn't matter. Forget that. Game, start. Here we go. So, that sets your shaders. So what I want to do is just move it to a different location so that we can see around us. So what I'll do is I'll take the window and we will set camera translation to an XYZ. X across will take 50 by 50, isn't it, that we're using? Hmm. 50? No. Let's make it 40.0f. Naught. No, we'll put it at 1.0f up. And Z, I want positive, so that's 40.0f, that's south. That might work. That might work. Oh, boom. Why isn't it overloading them? It's a link error. And it's telling me that Amber 3D OpenGL Window 3D, the update Window 3D void isn't correct. And it's coming from camera 3D rotation. Unresolved external symbol. Float class QVector 3D const and. Float class. Coming up on the rotate. I didn't ask it to rotate. And it didn't come up as a problem before. I've done something wrong with my rotations. Okay, let's see if we can see it. If I can't see it, then I can't do it. Today, that is. What I'm going to do is exclude from project for a second. Make sure there's no silliness going on there. And it's on the rotations. Rotation should be right. Did it say rotation or set rotation? Rotate. Oh, it's on 3 of them. That's interesting. So rotate. It can do that one, but it can't do that one. Translate, it doesn't seem to like the delta y, x, y, z. Okay. Alrighty. Okay. So what do I need to change in here? No, not yet. Okay. No, not yet. What do we need to? Entity. Add existing files. You and you. Okay, you and you. You. What is going on here? What's going on with camera here? For God's sake. No idea about that. Existing files, let's do them one at a time then. Camera 3D, please. I've got camera 3D CPP. I'll add you. Right, that's your camera 3D added. Do we have Math. No. Right, well, whilst I'm here, I can just get rid of you. We can remove you. And nope, we have to do that from the other system. God, I hate this. Maths. And maths. Okay. I think we might be able to build it now. And there we go. Cannot call constructor directly. -F permissive. Well, thank you. You should be able to. It tells me that I can. F1. Where's F1? Yes, I can. I'm doing it wrongly. It's not an equal sign in there, is it? Constructs the identity quaternion. M_rotation equals whatever I put in there. Right, so what's it actually saying? Error. Qualified reference to Q quaternion is a constructor name rather than a type. In this context. Right, I got you. No, it can't be done. Got you. I just put too much in there. That doesn't help. I need another way to do it. Let's try a build again. Okay, the conjugate problem. Well, I don't want to see it there, you Burke. I want to see it where I've used it. I've done the same in transform, have I? Yeah, I have. So now we know how to do that. I can alter this now. So it is M rotation. And that is just the last bit. That there. Make sure my brackets are right. No, they're not. And there we go. It can show up now. What? Member? What? Emerald. You're right. There you go. Alright, I got my ordering wrong. So you come out. Cut. And paste. Okay, ordering is correct. I'm happy. Save. Okay, kick quaternion conjugate. Yes, I know. I haven't used it here, have I? No, I haven't. It's only in camera. Camera CPP. There it is. Okay, put the D on then. Jesus. I didn't know which one to use because it doesn't tell you. Right, that's a bit better, I think, now. Okay. Just build to start off with. Does it build? Nope. Undefined reference. Hello, Muppet. Are you going to sit right in front of that? Yeah, you are, aren't you? I can't see, love. Come on, move. Thank you. Good boy. So it's window that's calling it wrong? That's a float. Oh, it's an int. That's a float. That should be... Oh, it doesn't matter, it's a multiplication. Entity, const q vector 3D. So I've got a float and a... What? Oh, it's const and. There's something rather weird going on here. It's because it's all changed. Why is my const ending a problem? This is on the rotate, isn't it? Void camera 3D rotate. Const Q quaternion and delta rotation. I'm not overly sure that it's correct with that. Let me just close a few of these. It should be telling me here that it can't do it. But I know damn well it can. So it's on rot, it's on it. It's also on set translation and set rotation. Const and. Alright, I think I might be able to do my sets correctly. That's in here. Alright. I just don't want to force it into a Q vector 3D. I would prefer this to work. And I'm not sure why not. Yeah, even the set camera rotation float. Set camera rotation, yeah. Doesn't seem to be giving me much of a hint on it. I think it's because of the constants. Shouldn't bother this thing. Shouldn't bother it. I can understand this one, but I can't understand the other one. Unless they change things on the header file. But the header file should not be changed from what it is. So I'm only left with these consts here. But why are the consts messing it up? That's just telling that's a compiler thing. That's just telling, or the person that uses this, that we're not going to change rotation, and we don't change rotation. Rotation is just set to a different, onto our value. we're not changing any values. That's what const means. We're not going to be changing that value there. Out of line definition. Oh yeah, of course, yeah. What? I see. Right. Get rid of all this constantness. Don't care. Don't care. Just getting rid of all consts. Take them all out until this damn thing stops messing me about. I'm going to have to read up on C++ 17 constants. Const. On there. Any others I can see? No. Yeah. Just take them out. Don't care. I'll put them all back in later. But for now, I'm just going to take them out and see if I can get it working first. Because I know that these things can really, really, really get iffy about it. Alright, let's go through all of these and get the consts out. That's done that. Okay. Let's see if we can get it working this way. Magic. Now we're getting the correct things. Let's go through these now. Are we still getting stupid things on? Yeah, we are. What the hell? Okay. That's create view matrix. We'll stop using it. Yeah. So create view matrix can come out. Oh, I've taken it out. What are you still doing it for? Pardon? Why are you still doing create view matrix? Not in your profile, is it? I told you not to delete it, but I didn't want you to damn well put in here. Sources. Why are you doing it? I don't understand. Not even. Ah, it is. It's there. Okay. Alright, get rid of that one. We should still have problems. I think it's doesn't like what I'm trying to do. No, don't do that. Rebuild. Why is it trying to do create view matrix? There we go, that's the real reason behind it all. Because that can't be converted into a Q matrix. It can. Alright, I'm going to have to look at this because it's not functioning the way it's supposed to. Which is fine. Anybody know why it's still trying to do this thing here? No, it's alright. We'll leave it with me. That is the camera. The const side of it is absolutely correct. There's no reason for it not to be there, but it looks like that's going to cause problems. So I'll just take it out for now. And as we go on tomorrow morning, we should be able to get this camera working. I can't see why not. I think it'll be simple enough. It's just playing silly buggers with me for some reason. No idea why. Function definition for rotate not found. That's interesting. Anyway, I'll have a look at that a bit later on, I think. After I've got a clearer mind. Cancel. No. Because whilst I'm here, I can now delete. Yes, I can now delete. Because I will get this working by tomorrow morning. No pressure. And we can get rid of that. Anything else I want to get rid of? Nope, looking good. Just make sure we haven't got cameras or silly things in here. So it's under entities and math. Okay, we're okay there with entities, I think. Yep. Yep, that's now correct. So it's still being referenced is why. I haven't taken the includes out. Wish it's just said that to me. So that's M2. There should be a third one somewhere, and that should be in the GUI. It should be here. Just clean that up a bit. Might help. So as you see, Qt Creator didn't give me the correct thing. Ah, now we're getting it properly as... That's better. That's better. That's the error. Right. I can work with that. Lovely. I will catch you all tomorrow morning. Now I know what the error is. And yeah, I think we'll have a fine sailing time as we rope into get the camera up and running, and we'll have ourselves running around first person around on our world map, which isn't fantastic at the moment, but we'll try and do a bit better. But there are some experiments I wish to do, yeah. There's a couple of experiments I'm thinking of doing. So we'll have a look at those later. And in the meantime, take care. Enjoy. And I'll pop this up onto in its current state. It's got a chance. So camera 3D. 3D integrated into Amber 3D. There we go. Full stop. Errors to fix before proceeding. All day. Lovely. You've got the code. If you can work the errors out, go ahead. Pop it in the down in the comments. Tell me what I did wrong. I don't mind. I'm not perfect. I am far from perfect. I am completely brainless at times. So that's where we're up to. We have a camera. We have transforms. We have bad constantness. Constant. Yeah, right. But we'll have fun figuring it all out. I can assure you of that. That was interesting. So, take care. Catch you tomorrow morning.